In today's video, we will be discussing polypeptides and proteins. And again, polypeptides, they are one of the condensation polymers. Polypeptides are also polyamides, and they are formed from a single amino acid monomer or many different ones. So you might have one amino acid or more than one amino acid. And as you see here in this amino acid, an amino acid has both an amine group and a carboxylic acid group. So, the amine group of one amino acid can react with a carboxylic acid group from another amino acid. When we have two amino acids that they are reacting like that, they will form what we call a polypeptide. So, a water molecule that will be eliminated. Here, the OH group from the carboxylic acid functional group in the amino acid will go and attach to the hydrogen atom from the amine group in the other amino acid. And the water molecule will be eliminated, and there is an amide linkage that will be formed, which is C double bond O and H. This is our polypeptide. When you have repeated units from this peptide, you will have the polypeptide. And polypeptides, they form our proteins, the proteins that are found inside our body, and that is the building block for the muscles, the other organs that function inside our body. Nylon, which we have seen in the previous video, which is an example of a polyamide, it is different from the polypeptide because the nylon comes from a diamine, which has the amine group alone, and with a dicarboxylic acid, which has the carboxylic acid group alone. However, a polypeptide, it comes from an amino acid which carries both functional groups, the amine group and the carboxylic acid group, in one molecule, which is the amino acid. This is how they are different from each other. Now, let's examine how to identify the repeat unit of a condensation polymer. If I have a condensation polymer like this one, how can we identify the repeat unit? Well, the repeat unit of a condensation polymer is found by starting at any point in the polymer and stopping when the same pattern of atoms begin again. As you can see here, the repeating unit is between those two square brackets, and you can see it starts at C double bond O A and it ends at the same beginning of this repeating unit, which here after the square bracket here it starts again from C double bond O A. So like that we can identify and locate our repeating unit. Now let's move to the third point, which is identifying the monomers of a condensation polymer. The monomer that we began with at the beginning of the reaction in order to get our long polymer. Let's take an example here. This is a chain that shows you the repeating unit inside a polymer. The first step in order to identify a monomer, you have to start with locating the repeating unit. And here it is already located between the two square brackets. This is our repeat unit. 2, which is the second step, you should break the linkage. If we have a polyester, we should break the linkage at the CO bond. And if we have a polyamide, we break it at the CN bond. But here we have a polyester, so I break the linkage at the CO bond. After I break the linkage, I add the components of water. Didn't we say that in a condensation polymer, a water molecule will be eliminated? I retain this water molecule again here. So I have to add OH to one side and H to the other side. So here I add OH to the C double bond O, as you see here, and I add H next to the OBO. Alright, I add H. So this is the same process when condensation polymers are hydrolyzed. By hydrolysis or hydrolyzed, I mean adding water molecule.